Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to divide by imaginary numbers and by complex numbers. Now this is similar to an issue that we run into when we have a radical in the denominator. We're trying to rationalize it. You can think of I as the square root of -1, that's a square root in the denominator, but really what we're trying to get to are answers of the form a plus bi, where the I is not in the denominator. So a complex number is of that form, and that's what we're really trying to get to here. Now, the problems that we deal with today, there's really two different types. If you look at the two at the top, 7 over I, -9 over 4i, you'll notice that in both cases, those are imaginary numbers in the denominator. And our strategy for those is going to be different than the next two at the bottom of the screen, that have denominators of 3 plus 4i or 4 minus 2i. Those are complex numbers, and those will have a different strategy as well. For the first problem, 7 over I, we handle this by multiplying both the numerator and denominator by I. And we'll see why we do that in just a second. Multiplying straight across the top, 7 times I is 7i. Multiplying in the denominator, I times I, that is I squared. So far it doesn't seem like we've done anything, but we really have, because I squared is equal to -1. So we have 7i over -1, but that is just simply -7i. 7 divided by -1 is -7. So that is in complex form 0 minus 7i. For the next one, even though there's an extra factor of 4 in the denominator, we handle it the same way. Multiply the numerator and denominator by I. So -9 times I is -9i. In the denominator, 4i times I, that is 4i squared. Now we know from the last video, 4i squared is really the same as -4. So we've got -9i over -4. And we can simplify that fraction a little bit, because dividing a negative number by a negative number is positive. This becomes 9/4 I, writing the I after the fraction. For the bottom two, we're going to use the idea that we developed in the last video about conjugates. We know that if we multiply a complex number by its conjugate, we get a real number, and that's the way that we're going to get I out of the denominator here. Looking at problem 24, 5 over 3 plus 4i, we're going to multiply the numerator and denominator by the conjugate, 3 minus 4i. In the numerator, we've got some distributing to do. 5 times 3 is 15. 5 times -4i, that's minus 20i. In the denominator, because these are conjugates, we had that rule that said a plus bi times a minus bi is equal to a squared plus b squared. So in this problem, the a is 3 and the b is 4. That gives us 9 plus 16 in the denominator. Now, you could have multiplied that out using a FOIL style of multiplication. 3 times 3 is 9. 3 times -4i is -12i. 4i times 3 is positive 12i. And 4i times -4i is -16i squared. The two middle terms are opposites and add to be 0. -16i squared is the same as positive 16, and so that's where we would get the 9 plus 16 from. Let me get rid of that. And now let's go ahead and try to finish up this problem. Need to simplify the denominator. 9 plus 16 is 25. So we have 15 minus 20i over 25. Those three terms, the 2 in the numerator and the 1 in the denominator, all have a common factor of 5 that we can divide out. 15 divided by 5 is 3. -20 divided by 5 is -4. 25 divided by 5 is 5. We're left with 3 minus 4i over 5. If we want to split that up and write it in a plus bi form, we can do that. That would be 3/5 minus 4/5 I. You can also break it up first and then try to simplify or reduce afterwards if that works better for you. Problem 25, similar idea, except this time the numerator is imaginary. Not really much of a difference though. we're going to multiply on the top and the bottom by 4 plus 2i, the conjugate of the denominator. Distribute on top. 15i times 4 is 60i. Plus 15i times 2i, that's plus 30i squared. In the denominator, those are conjugates, so we can multiply a times a, b times b. We've got 4 squared, or 16, plus 2 squared, or 4. And let me just write that to the side. 4 squared plus 2 squared. That denominator is going to simplify to be 20. Also, this 30i squared is really the same as a negative 30, so I'm going to rewrite everything in order in the numerator. Negative 30 plus 60i over 20. Now, in the last problem, I said you could split first and then reduce. Let's show you what that would look like. I can rewrite this as negative 30 over 20 plus 60i over 20. And then I simplify each fraction. 30 over 20, there's a common factor of 10. That can become negative 3/2 plus 60 over 20. 60 divided by 20 is 3, so that would be plus 3i. I think it's easier to reduce as much as you can first and then split it, but it's really a matter of choice. 2 more to go. These last two, the numerator, instead of being a real number or an imaginary number, now we have a complex number. 5 minus 5i is a complex number, over 3 plus I is another complex number. We're going to multiply the numerator and denominator by the conjugate of that denominator, 3 minus I. In the numerator, this is a FOIL style of multiplication. Distribute the 5. 5 times 3 is 15. 5 times negative I is minus 5i. Then distribute the negative 5i through. Negative 5i times 3 is minus 15i. Negative 5i times negative I, that's plus 5i squared. In the denominator, using that a squared plus b squared idea, a is 3, b is 1, 1i. So it's 3 squared plus 1 squared. A little simplifying to do here. First, 5i squared, that's the same as minus 5. Combine that with the real number 15 in the numerator. 15 minus 5 is 10. We've got 2 like terms to combine. Negative 5i minus 15i, that's negative 20i. And in the denominator, 3 squared is 9 plus 1. 9 plus 1 is 10. So here, we can split this up and reduce, or reduce and then split. It's really your choice. I noticed that everything has a common factor of 10, so I'm going to start there. 10 divided by 10 is 1, minus 20i divided by 10, that's minus 2i. And 10 divided by 10 in the denominator is 1. But we don't write a denominator of 1. Division by 1 doesn't change anything. So this just becomes 1 minus 2i. We'll do one more. Negative 3 plus 4i over 2 minus i. Think about what you're going to multiply by. If there is one term in the denominator, an imaginary number, multiply by I over I. In a case like this one where you have 2 terms in the denominator, multiply by the conjugate. So we're going to multiply by 2 plus I here, top and bottom. I'm going to quickly distribute on the top, starting with the negative 3. Times 2 is negative 6. Negative 3 times I is minus 3i. Now for the 4i, positive 4i times 2, that's plus 8i. 4i times I, that is 4i squared, and that's positive. Downstairs, 2 squared, 2 times 2 is 4, plus 1 squared, 1 times 1 is 1. Remember that this 4i squared is really the same as negative 4. So in the numerator, there's a negative 6 and negative 4 to combine, that's negative 10. Negative 3i plus 8i is plus 5i. In the denominator, 4 plus 1 is 5. And again, just to show you there's more than one way to do this, I'm going to split this into 2 fractions and then simplify each one. So I can write this as negative 10 over 5 plus 5 over 5i. Negative 10 divided by 5 is negative 2, plus 5 divided by 5 is 1, 1i, or simply I. I could have divided the 5 out of all three terms in the original fraction. Negative 10 divided by 5 is negative 2. 5i divided by 5 is 1. 5 divided by 5 is 1. We'd get to the same place. All right, that's it for division by imaginary and complex numbers. The last video in this series is going to involve powers of I, including ones that are greater than 2.